Multiplying radicals. So we've looked at adding and subtracting radicals. Now we're getting into multiplying radicals. Remember, in order for us to multiply radicals, you have to have a common index. So the indices here, the common index is 2. The square root of 2 times, in parentheses, the square root of 3 plus the square root of 5. So just like we would if I gave you an expression such as 2 times 3x plus 5, you would tell me that you would use the distributive property. Well, we're going to do the same thing here. Remember, whenever we're multiplying like radicals, when we're multiplying radicals with a common index, we can multiply the radicands. So we're going to use the distributive property to multiply these radicals together. So you have the square root of 2 times the square root of 3. Let's show the work to this. Square root of 2 times the square root of 3. Multiply 2 and 3 together, and we have the square root of 6. Then take the square root of 2, multiply it to the square root of 5. Square root of 2 times the square root of 5, we have the square root of 10. Bring your radicals, or bring the parts together, so we have the square root of 6 plus the square root of 10. My question to you is, can you add these radicals together? The answer is no, because in order for you to add or subtract radicals, the radicands must be the same. And these radicands are not the same, 6 and 10. So this is our answer. Square root of 6 plus the square root of 10. So just like in the last, your last test when we talked about multiplying polynomials and we had to use the distributive property, well, the added um, topic here is radicals. So here we have a monomial, which is the square root of 2, times a binomial, which is the square root of 3 plus the square root of 5. We had to use the distributive property. Now remember, when we talked about multiplying polynomials in the previous section, whenever you're multiplying two binomials, you're using the FOIL method. What's added to this section is that we have radicals. So we're going to take our time with this as we distribute, because I don't want it to be you to be confused with how to multiply radicals, but we're going to be using the FOIL method. So here we go. We're going to take this 3 square root of x, multiply it to the 4 square root of x. Let's write that out. And we're going to simplify it, meaning we're going to multiply. Multiply 3 times 4, that's 12. Multiply the square root of x times the square root of x, that's the square root of x squared. Now, if you can simplify the radical, do so. The square root of x squared, that can be simplified. That would give us x. So our answer for the first term is 12x. The outside terms, the factors of the outside term. You're going to take 3 square root of x, multiply it to the 7. So 3 square root of x times 7. Combining your like factors, 3 times 7, that is 21. And then we have the square root of x. There's nothing that we can do to that. So just write 21 square root of x. So we're finished with the 3 square root of x. Let's look at the 5 and distribute that twice. So inside terms, you're going to take the 5, multiply to the 4 square root of x. 5 times 4 square root of x. Multiply your like factors, 5 times 4, and then we have which is 20, and then we have the square root of x. And then we're going to take this 5, multiply it to the 7, that will be factors of the last term. 5 times 7, that gives us 35. Now let's bring together our parts. We have 12x plus 21 square root of x plus 20 square root of x plus 35. Look and see if you have any like terms, and then look to see if you have any like radicals. I see some like radicals. Meaning we're going to add 21 and 20 and keep the radical. So bring down your remaining terms. Bring those down. So our answer is 12x, and then we have 21 plus 20. Those are square root of x, the like radicals. That would give us plus 41 square root of x, and then plus 35. That is our solution. We don't have any like terms. This x that's next to the 12 is not the same thing as the square root of x, the radical. They are not like terms. So we are finished.